Okay, combinations. As part of the grade 12 English course, students were required to read 3 books in a 3-month period: The Grapes of Wrath, The Wars, and The Bean Trees. Due to previous late returns, Steve is only allowed to take 1 book out from the library at a time. List all the different ways in which Steve could sign out the books. And we'll use G for Grapes of Wrath, W for The Wars, and B for Bean Trees. So that would be one possible order. What would be another possible order?
BWG.
Okay.
WG.
Okay.
BGW.
So there were 6 possible orders, 6 ways that I can take these books out. Tariq, on the other hand, is allowed to take all 3 books out at the same time. So how many ways can he sign out all 3 books at once? Don't overthink it. 1 way.
Okay.
Because it doesn't matter when he comes up to the front desk, it does not matter if he gives the librarian The Grapes of Wrath, The Bean Trees, and The Wars, what order she scans them in, because when he leaves the library, he has all 3 books. Okay? Whereas Stephen comes into the library, returns The Bean Trees, and takes out The Wars, and The Grapes of Wrath stays on the shelf. He only leaves the library with this book, and then a month later exchanges it for a different book, and so on. Tariq gets to take all 3 out at the same time. So with Stephen, order is important. It matters which book he takes out first because that's the first book he reads. With Tariq, order is not important. He takes them home and then he can decide which order he's going to read the books in. So Part A is called a permutation because the order is important, whereas Part B with Tariq, that's a combination. Order does not matter. And it's a bad word to use because when we think of combination locks, a combination lock is actually a permutation because it's important what that first one is. So it's terminology that is a little bit backwards to our thinking, but with a combination, the order is not important. So suppose that instead you're only required to read 2 of the books. Okay? So it says, complete the table to show the number of ways in which Steve and Tariq could do this. So Stephen can take out The Grapes of Wrath and The Wars. He can take out The Grapes of Wrath and The Bean Trees. He can then take out The Wars followed by The Grapes of Wrath. What else could he do? He could take out The Wars. And what else? Bean Trees. Or he could start off with Jessica's favorite book, The Bean Trees. And then follow it up with The Grapes of Wrath. Or The Bean Trees and The Wars. So again, Stephen still has 6 possible ways that he could take those, or 6 orders in which he could read 2 books. Tariq can go to the library and he can take out The Grapes of Wrath and The Wars. Doesn't matter what order he takes them out. He's taking them both. He's putting them in his locker. He's bringing them home. He can read them any way he wants when he gets home. Or he could take out The Wars and The Bean Trees. same as this order and this order. So he takes out basically 2 of Stephen's orders. Or he could take out the grapes of wrath and the bean trees. Which would be those 2 orders. Because again, it doesn't matter how he takes them out, he has both of them. So the number of combinations, which is 3, is equal to the number of permutations, which is 6, divided by what? So 6 divided by what equals 3? 2. Which can also be a 2 factorial. So a permutation is an arrangement of elements in which the order is taken into account. A combination is an arrangement where the order is not considered. So 5 students, Al, Byron, Colin, Dave, and Eric, take part in a cross-country race. The winner of the race wins $50, the runner-up wins $25, and the third place runner wins $10. So this table below shows all the possible ways in which the 3 prizes could be awarded to the 5 participants. Is this a permutation or a combination? Does it matter who's picked first? Yeah, because who's picked first gets how much money? $50. So I want to be the first prize winner, not the third prize winner. So this would be a permutation. So how many ways could I award the 3 prizes? Well, I could look at this with the fundamental counting principle. I have 5 ways to award the first prize. 4 for the second, and 3 for the third, which is 5 times 4, which is 20, times 3, which is 60, which is also the same thing as I'm given 5 and I pick 3. Now, if you participate in this cross-country race, the school's been awarded 3 places at a running clinic. The school coach decides to select 3 lucky students from the ones who took part in the race. So the table, which was duplicated from the one above, because I'm pulling really the same orders out, but in this case here, does it matter if I pick Al first, before Byron and before Colin? No, because all 3 of them get to go to the same event. There's no precedent, there's no favoritism, there's no privilege to picking the one over the other. So this becomes one group. And then I have Al, Byron, and David. Is that who D is? Dave. Become the next group. And again, it doesn't matter if I pick Byron over Dave, they're both going to this clinic. So there's no importance to the order that I pick them in. So each of these now becomes its own grouping. Because it doesn't matter the order in which the 3 players or the 3 runners were chosen, it just matters that they were chosen. So this is a combination. So if I look at the number of groups that I circled, how many groups did I circle? 10. So the number of permutations was 60. What can I divide 60 by to get to 10? 6. factorial, what is 6 equal to? 3. And using the example, how could I come up with the 3 factorial?
Well, there's 3 spots.
There's 3 spots. Okay, good. So we do have a formula usage for combinations. That was taking the permutation and dividing it by r factorial. So if I look back on this page, in terms of permutations, I had 5p3, which I then divided by 3 factorial. So that's the first part that's shown, this part right here. On your formula sheet, you're not given this. What you're given is this part. So I can get that by taking my NPR. So from the last section, my permutation formula was n factorial divided by n minus r factorial. And then that's divided by r factorial, which means the r factorial stays at the bottom as well. So that's how that formula is derived. Sometimes you will see NCR written in this form with a set of brackets and the N at the top and the R at the bottom. It is a notation that can be used on your diploma, so it is something to be aware of. If you saw that, it would mean that it's a combination question. Okay. 3 students from a class of 10 are chosen to go on a school trip. So if I pick 3 students from your class to go on a school trip, does it matter who I pick first? No, because all 3 people are getting to go on a trip. So that's what makes it a combination. So how many ways could I select them? So that is, I have 10 to choose 3. So in terms of factorial, my factorial formula is this. So n factorial, n is 10. And then I have n minus r, which is 10 minus 3, so 7 factorial, and r factorial. So I could expand this out, 10 factorial, 10 times 9 times 8 times 7 factorial, so I cancel the 7 on the bottom. And then I expand it out. We did a question similar to this with the 3 and the 2. And then 8 divided by 2 is 4, 3 divided by 3 is 9, so now I have 10 times 4 times 3. Or you can use the NCR calculator key, or the key on your calculator, which is the same as the NPR. You find it in the same place, it's just choice number 3. Okay? Lotto 649 is an example of a combination, because when you participate in Lotto 649 and you're given your ticket, tickets are always printed in numerical order. If you watch, and they do actually record all of the Lotto Max and the Lotto 649 draws are recorded. I'm not sure where you can watch them. You used to be able to watch them like on CTV before a certain time on whatever day. But they do record them for documentation purposes. When the balls come out of the chute, they're not coming out in numerical order. So 47 might come out before 4, but it doesn't matter. I list them in numerical order so it's easier to check my ticket. Okay? So to win Lotto 649, a person chooses 6 numbers between 1 and 49. Jasper selected the birth dates of his family, 3, 7, 9, 11, 20, and 29. How many different selections could he have made? So this is a combination. I'm choosing 6 numbers. How many numbers do I have to choose from? Be 49, because it would be 1 to 49, not 0. Because number 1 would be your first choice, number 2 would be your second. So what'd you get?
Because you have to pick 6 numbers on 49. I didn't realize that. 13,983,816.
So you've got almost a 1 in 14 million chance of winning the Lotto 649. Which means now Lotto 649 costs you $2. In theory, it means if you had $28 million, you could guarantee yourself a victory. However,
It's not worth it. The bottle's worth more than that.
definitely if it's not worth it, worth more. The problem being, if it's a $60 million, or actually if it's a $40 million pot, $40 million could be worth it. Spend 28, I guarantee myself a $12 million profit. Unless there's another winning ticket. Because if there's 2 winning tickets, that 20 million gets split. Or sorry, the 40 million gets split to 20. You've now lost $8 million. Which is why the bank would not lend you $28 million to play Lotto 649.
Unless you're a celebrity and you had $20 million.
In which case, why would you spend $28 million?
That's true. Piss people off.
Okay, the Athletic Council decides to form a subcommittee of 7 council members to look at how funds raised should be spent on sport activities in the school. There are 15 athletic council members. There are 6 females and 9 males. The subcommittee must consist of exactly 3 females. So the question is, how many ways can I select 3 females? So is order important? Does it matter which female is picked first? Okay, so that makes it a combination. How many females am I picking? And how many do I have to pick from? So what is 6C3?
20.
Okay, so there's 20 ways to pick the females. What about the males? How many ways can I pick them?
We have 4 spots for males, right? So
Okay.
it'd be 9C4.
Okay, and how many ways would that be?
126.
So how many ways can I form the subcommittee? That has to have exactly 3 females. So the number of ways to pick the females and the number of ways to pick the males. What'd you get, Evan?
2,500.
So there would be 2,520 different subcommittees that could be arranged. How many subcommittees could I arrange if Bruce, who's the football coach, has to be included? So now I have Bruce, I have the females, and I have the males. So how many ways can I pick Bruce? 1 way, just Bruce. And then the females, I still need 3 of them, so it's still going to be 6C3. How many males do I need on the subcommittee now? 3. 3 because I already picked Bruce. And how many males do I have to choose from? 8. Good. How many committees?
6,720.
Nope. It should be less than what I had before.
1,000.
Can I see what you did, Rachel? Let me just see your calculator.
You try turning it off and back on.
Oh, you multiplied
It
by
doesn't even
100.
turn
Did
on.
you put it in rice?
No, this is 20. That's fine.
Jessica's
Okay. What's that?
It won't turn on. Is it
Your
bad?
batteries?
No, last time I checked, like the battery was still green and it lasts quite a while. Like usually it could be in the yellow for like a week.
And it hasn't turned on at all today?
No,
Did you leave it in your car overnight?
no, I didn't. It's always in my bag, which is always in the school or in my house or at work.
So not.
No,
You change batteries.
you charge it.
A lot of combination questions that are used are card questions. Because when you are dealt a hand of cards, you rearrange the cards. Everybody has their own system for how they organize the cards. You will not see a card question on the diploma because there are certain things to a card question that you have to make sure of. You would have to put all of this stuff and make sure that students understood what's in a deck of cards. Because believe it or not, there are people that just, they don't. They don't play cards, they don't handle cards. So a deck of cards, a standard deck of cards, does not include jokers. It has 52 cards. There are 4 suits: spades, clubs, diamonds, and hearts. 2 of the suits, clubs and spades, are black. 2 of the suits, diamonds and hearts, are red. There are 13 cards in each suit. Face cards are your jacks, your queens, and your kings. And depending on the game that you're playing, sometimes your ace is your high card, sometimes it is your low card. So that's why a card question is not put on a test, because if you've never seen a deck of cards before, you're now at a disadvantage. The idea being we want to test your knowledge on combinations, not on knowing a deck of cards. There's also some cultural impact to using cards, and that's another reason why they're not shown. But we can use them for our question because there's no cultural thing here, and I think you guys all know what a deck of cards looks like. And then we talk about poker. So poker is a 5-card hand, and it's played with a deck of cards. So how many possible poker hands could you have? So does order matter? Does it matter the order that I'm dealt the cards? No, because I shuffle them around, so this is a combination.
Yeah.
How many cards am I given? That's how many I have. And how many are being dealt to me? 5. So how many cards would that be?
$2,598,960.
Different possible hands.
How do I put the numbers in?
You have to start by putting the N in first.
52.
Oh, okay.
Okay. It's okay. How many of the hands would be all diamonds?
Would it be like 13?
Exactly. So what is 13C5?
1,287.
4 black cards and 1 red card. So how many, what are my combinations? combinations for the black cards?
13 combination for black.
Not 13. How many black cards do I have?
Be 26.
Right. So 26 C4, and then my red cards?
26 C1.
Okay. So how many hands would that be? Oh, right, sorry. How many did you get?
You're supposed to multiply them.
Yes.
Not right. 388,700.
Because again, we've got that word and. The black cards and the red cards. 3 kings and 2 queens. So how many ways can I pick 3 kings?
4 C3.
Yes. And how about the queens?
4 C2.
Mm-hmm. Yep. How about picking just 3 kings? So if I'm picking 3 kings, what else do I have in my hand? Anything else. So I have 3 kings and 2 others. So how many ways can I pick my 3 kings?
4 C3.
Yes. And what about the 2 other ones?
48 C2.
48C2. That is correct. Okay, what about 4 aces?
Only one way you can do that.
That'd be only one way. But if I have 4 aces, what else do I have to have?
Oh, was it?
One other card. And how many ways are there to pick that one other card?
48 C1.
48C1, which even if we didn't use our calculator, let's think about this logically. How many ways are there to pick one card out of 48?
48.
There's 48 ways. So you think about that. You've got a 48 in a 2.6 million chance of getting 4 aces. So when you decide to go play poker for money, that's why it's called gambling, because really the odds are not in your favor. 5 cards of the same suit. It's called a flush. So what that means is I could have 5 clubs or 5 hearts or 5 diamonds or 5 spades. So how many ways can I pick 5 clubs? Look at number 1.
13 C1.
13C5, the same way that I can pick 5 diamonds. So this would be 13C5 how many times?
4.
4.
1,148.
Different hands to give you a royal flush. Or sorry, a flush. A royal flush is if you have ace, king, jack, ace, king, queen, jack, and 10. Which again starts to become much more limited because in that case, that's no longer a combination. That gets some of the permutation because it matters which 5 cards I get. In this case here, it doesn't matter which 5 cards I have, as long as I have 5 hearts. Okay, so your questions to practice, 5, 7, and 8, 10, 11, and 12.
So
Put it that way. I know, I wanted to do the first one.
What's that?
The first one was a pizza question. It's decent all around.
Well, you can do that one.
Oh,